Betelgeuse is an enormous star, estimated to be about 15 to 20 times more massive than our Sun, and it is approaching the final stages of its stellar life. This colossal and radiant celestial body is destined to explode in a spectacular supernova event. Recently celebrated physicist Brian Cox shared intriguing insights, stirring public interest. According to him, Betelgeuse, one of the most brilliant stars in the Orion constellation and the night sky overall, is nearing the point of a supernova detonation. Data collected by astronomers corroborate this looming cosmic occurrence. This raises a vital question. Are we on the verge of witnessing a cataclysmic stellar explosion, or is this merely theoretical? Let's explore the potential hazards posed by Betelgeuse and examine the cautionary statements made by Brian Cox regarding its explosive future. The massive red supergiant known as Betelgeuse, named for its distinctive brilliance, outshines many of its neighboring stars and is situated in the Orion constellation, specifically marking the hunter's left shoulder. Though it has long fascinated astronomers due to its unusual characteristics, recent discoveries have heightened interest and speculation about this remarkable object in space. Typically, a star is classified as a supernova candidate if its mass is at least 8 times that of our Sun. Betelgeuse, however, defies convention. It is over 700 times larger in radius than the Sun, and more than 15,000 times as massive, far surpassing initial expectations. The earliest documentation of this celestial giant traces back to the Greek astronomer Claudius Ptolemy, who could only infer its properties based on limited data such as color and sky position. As astronomical tools and observational techniques advanced, so too did our understanding of stars like Betelgeuse. This aging red supergiant, now estimated to be between 8 and 8.5 million years old, a venerable age in stellar terms, continues to gain mass. If Betelgeuse were placed at the center of our solar system, its enormous radius would extend well past the orbits of Mercury, Venus, Earth, and Mars. Its sheer magnitude astonishes scientists and deepens curiosity about how such a star could accumulate so much mass. Astrophysicists explain that Betelgeuse's size is not random, but a natural consequence of its evolutionary trajectory. Currently, it exists in the late stages of stellar development, characterized by a cooling expansion and ongoing fusion of hydrogen into helium within its core. This red-hot, voluminous phase is known as the supergiant stage, a culmination of millions of years of nuclear and gravitational processes. Over time, it transformed from a hot blue main sequence star into the massive red giant we see today, with nuclear reactions and gravity driving the metamorphosis. Its red hue results from a relatively cooler surface compared to other stars, such as the Sun. While the Sun has a surface temperature of approximately 5,500 Kelvin, Betelgeuse's outer layers register closer to 3,500 Kelvin. This cooler temperature shifts its light emission toward the red part of the spectrum. Just as its vast size reflects its evolutionary growth, its coloration reveals key information about its condition, gas dynamics, and scale at any given moment. Historical accounts from Chinese and Roman astronomers suggest that around 2,000 years ago, Betelgeuse appeared yellow. The earliest confirmed observation of it being red comes from 9th century Arabic scholars, offering critical insight into its transformation across centuries. In addition to color, Betelgeuse's luminosity is another intriguing aspect. Classified as a semi-variable star, its brightness fluctuates over time. This variability has captivated astronomers for generations. Typically, Betelgeuse undergoes brightness cycles lasting around 400 days, with longer oscillations spanning up to 5 years. These changes were first formally recorded in 1836 by Sir John Herschel, though indigenous Australian oral traditions may have noted them even earlier. Unlike many stars that follow predictable cycles, Betelgeuse exhibits irregular brightness changes, brightening and dimming unpredictably. This unusual behavior hints at complex internal mechanics. In 2019, the star drew global attention when it unexpectedly dimmed, a phenomenon dubbed the Great Dimming. Betelgeuse's brightness dropped by roughly 0.1 magnitude per day, reaching its dimmest point by February 2020. Although typically visible even in light-polluted skies, Betelgeuse appeared markedly fainter during this episode. The dimming, which occurs roughly every 430 days, has been linked to dark patches, akin to sunspots, forming on its surface. Understanding Betelgeuse is complicated by the fact that we observe it as it appeared roughly 725 years ago, due to the time light takes to reach Earth. This time lag presents challenges in forecasting future events. However, observations from the Hubble Space Telescope have been instrumental in uncovering clues about Betelgeuse's activity. Hubble's ability to detect ultraviolet wavelengths allowed researchers to study its upper atmospheric layers and detect turbulent convection currents. Moreover, the ALMA Observatory in Chile provided high-resolution images revealing massive gas plumes extending from the star. In February 2021, Betelgeuse underwent another dimming event, dropping to a V-band magnitude of probably 1.64, fainter than normal. The star's magnetic field, believed to be thousands of times stronger than the Sun's, traps gases in looping arcs and causes intense magnetic activity. Giant star spots, cooler, darker regions where this magnetic field is strongest, can cover up to 20% of its surface and significantly influence its brightness. As Betelgeuse edges closer to its end, researchers theorize that the dimming episodes, mass ejections, and dust formation could all be early signs of a supernova. The James Webb Space Telescope has detected evidence of a past outburst, during which the star shed a substantial portion of its visible surface, expelling clouds of dust, further strengthening the theory of its imminent demise. Although periodic, dimming is a typical sign of an aging star. These other occurrences are rare and perplexing, prompting further inquiry. Our own Sun also loses matter through coronal mass ejections, yet none are as dramatic as the events seen on Betelgeuse. Thanks to the James Webb Telescope, scientists can further explore the reasons behind these violent mass ejections. It is understood that as nuclear fusion wanes, stars begin to shed mass. This loss rate is a key factor in determining their fate. For Betelgeuse, this significant mass loss could signal that a supernova is near. Data from the Hubble telescope indicate that the 2019 dimming was due to a massive ejection of superheated plasma. This material cooled and condensed into dust particles that veiled the star, reducing the light that reached Earth. The expelled material was traced back to a convection cell, and as it cooled, it settled into a cloud that blanketed part of Betelgeuse's surface. These observations, enabled by Hubble's ultraviolet spectrometry, helped scientists pinpoint the timeline of this major dimming. The amount of mass expelled was staggering, about 400 billion times what is typically released in standard ejections, surpassing the mass of Earth's moon. Betelgeuse moves through space at roughly 67,000 miles per hour relative to its local interstellar medium, creating a phenomenon known as a bow shock. Much like the wake of a fast-moving ship, this wave forms where the star's outer layers collide with interstellar gas and dust. This interaction not only creates a stunning visual, but also helps researchers understand the dynamics between aging stars and their cosmic environments. Since the major eruption, Betelgeuse has remained in an unstable state. Hydrodynamic simulations suggest a link between its internal convection, mass ejections, and changes in pulsation modes. The energy driving its pulsations appears to dissipate through shock heating, altering its regular cycles.